Greetings. This is a lecture on the topic of exploratory testing. The type of exploratory testing that I'm going to describe is known as charter-driven, session-based exploratory testing. When we say exploratory testing, we're generally implying here that the tester has the freedom to design and execute tests on the fly as they learn about the system that they're testing. When we say charter driven, there is a clear objective for the testing. There's a clear reason or purpose for the testing. And when we say session based, we time box the testing. That's not to say that all the testing has to finish within a time box. It's to say that after a time box, we're going to pause our testing, review what we've learned, and make a decision as to whether we should continue or move on to something different. So that's exploratory, design and execute tests as you learn. Charter-driven, have a very specific, well-defined purpose before you start. And session-based, time boxing the work. So those are the three elements for the type of testing we're describing, session-based exploratory testing. So that's my contact information. My name is Robert Sabourin. Many people call me Rob Sab, and I can be reached by email at robsab@gmail.com. Bio, run a consulting company called amibug.com. I'm an adjunct professor at McGill Engineering in software engineering, and have published and written a lot of books and articles about topics related to software engineering and software testing. Quite passionate about testing. So we'll take a look in this section at an example of exploratory testing, a little bit about chartering, and a framework for actually implementing exploratory testing. That'll be an organizational framework. So first of all, what is a common example of exploratory testing? Well, this is one that I have seen the most. And a lot of people practice this type of testing, and they don't necessarily realize that it is exploratory testing. But nonetheless, it is. In fact, it's one of the most important types of exploratory testing. And that's called bug confirmation testing. Bug confirmation testing. This is a type of testing that occurs when a bug has been fixed by a programmer and someone is confirming that the bug was really fixed. The bug is not there anymore, and furthermore, there are no adverse side effects. So this is a type of testing that a lot of people do. Any project you ever worked on, when you fix a bug, you don't just take the programmer's word for it. You check it, you test it, you see if it's really fixed. And you could use tools to help you with this, or you could do this with automated tools or manual testing, depending on the context, depending on the project you're working on. But the goal is to confirm that the fixed bug is really fixed. We want to confirm that the bug didn't move. So sometimes when people fix a bug, it accidentally shifts it to a different place in the software. This happens inadvertently. And sometimes when you make a change in the code, you accidentally inject a new bug when you're fixing an old bug. Also, sometimes when you fix a bug, you expose another bug. So when you fix a problem that enables people to log in, after you fix that, then there's problems that show up after you're logged in that may have been blocked. So you have sometimes a bug, when you fix one, it exposes another bug that's been buried under there. So one approach to bug confirmation testing is to basically start by using the reproduction steps. Usually this is in the bug report, how to reproduce the bug, the steps you'd go through to reproduce it. So the first thing you do is you get a hold of those steps. They're very often in your bug documentation, in your bug report. We're going to confirm that the bug really is in the original build. So we've got to make sure that the bug was really there before, and then show that it's not there in the new build. So you have this sort of side-by-side testing approach where you demonstrate the bug was really in the old build, and then you take the new build and you show it's not there, side by side. So you have a very clean view that the bug is gone with this sort of approach. There's concern if the bug moved. So what you'll do to explore whether the bug is moved, and you don't know if it's moved, you might say, okay, what are related capabilities? So what parts of the system use the code that was modified to fix the bug, or use the object that was modified to fix the bug, or use the stored procedure that was modified to fix the bug, or the data that was modified to fix the bug. You look at related capabilities related by the code changes, and then you sort of vary the steps to reproduce the problem and investigate whether the features with shared code or shared objects still behave correctly. So we're basically looking at related capabilities, features that share common code, stuff like that. So we're exploring to see if the bug shifted or moved. We want to also check, did the developers inject a new bug? So here now we're going to exercise capabilities of the application by changing the data and walking through different scenarios. So scenario would be, what would a user be typically doing, and walk through that and walk through that and walk through that with different data every time to sort of make sure that we didn't inject a new bug. This, of course, doesn't guarantee we're going to find it, but it helps us gain confidence that the fix didn't introduce nasty behavior. Now, there's a beautiful approach that a specific tester I worked with for years called Jason developed, and he used this a lot. He started when he was asked to do bug confirmation testing. So this was his exploratory bug confirmation testing approach. The first thing he did was he would actually talk to the programmer, find out, what was changed and what the programmer did, get a feel for it. What was the programmer's view of the bug? And that's, for me, I like this approach. You start with talking to people. When you're doing exploratory testing, there's nothing that tells you can't talk to people. The developer is a perfectly reasonable person to chat with. Confirm the bug was in the old build, as we said in the sort of more common approach. Was the bug really there before? Is the bug in the new build? You might confirm it's not in the new build, so that means that we cannot reproduce the bug in the new build, but we can demonstrate it was in the old build. Then what Jason would do is he would imagine, what is a usage scenario? What is something a user would do that would have exposed to the original bug? So what is something the user would do that would have exposed to the original bug? And then he would walk through that scenario many times, but he would vary the steps, the order of execution, the order of data, how it was done. He would basically do perturbations on it and keep changing and changing and changing, and continue until he got to a point when, the way he described it, he said, where the perturbation was absolutely absurd. And for him, absurd would be that he would basically talk to any stakeholder on the team or any developer, and they would say, no one in their right mind would ever do that. So you get to the point where someone wouldn't do that on purpose. Maybe they'd do it if they're trying to break the system, but not if they're on purpose trying to use the system to get something done. So that's when he gets to what he calls absurd. So this approach, it was used, I saw this used for several years, and it was a fantastic exploratory testing approach to basically confirm that bug fixes were effective, that they really worked. So let's get into chartering the course. Exploratory testing should start with some sort of goal. Begin with the end in mind, as Steve Covey said when we looked at some philosophy. So begin with the end in mind. What's the goal? And that we will call the charter for exploration. It's the goal for exploration. It's really a statement of what you want to learn about. So in the charter, we'll basically express what the goal is of our learning. What do we want to learn about? And it could be as broad or as narrow as you want. It's very dependent on the project and the organization and where you are. I like charters to be quite specific, but I start with charters that are quite general. And here's an example from a charter from a real exploration. This is from Lewis and Clark, who in the States were commissioned by President Thomas Jefferson to explore, to find whether there was a passage by water to the Pacific Ocean. And he wrote this letter, which still exists. I believe it's in the Smithsonian now. And it's a beautiful statement of a charter for exploration. He says, the object of your mission is to explore the Missouri River system and principal streams of it, as by its course and communication with the waters of the Pacific Ocean may offer the most direct and practicable water communication across the continent for the purpose of commerce. Now, this was, of course, a mission statement for real geographical exploration in 1803, but it's a beautiful, beautiful capture of what is a charter. It's a goal. It's what we want to learn about. And what Jefferson wanted to know is there a route by water to the Pacific that we could use for trade? He was still looking for the Northwest Passage. And this, of course, happened after the Louisiana Purchase, where they acquired all that territory, and they wanted to learn what is in that territory. So that's the Lewis and Clark Charter, famous one from history. Well, in exploratory testing, our charter is a statement. It's a mission statement. It ties to purpose. It ties to why are we doing the project? Why are we doing the testing in the first place? The charter focuses our work. It tells us what to learn about or what we want to learn about. It's a charter that everybody on the team can see. It's not just hidden in your pocket. It's not just private to the person doing the testing. Everybody on your team can see it. And because of that, they understand what you're doing. What is the purpose of all these tests you're running? So this is going to be used by the whole team to confirm that we're in sync. We know where we're going. We know what we're trying to learn about. And also the charter helps us to scope things. It helps us to make statements of what's in or what's out, what type of data, what type of environment, what type of platform. Wherever there are restrictions, we can put scope in there too. So it's a mission statement. It's a statement of what we want to learn about. There's a lot of different types of charters, and certainly in different parts of this course, I'll spend time going through them. There's charters that can basically explore the capabilities of a system. It can explore the relationship between features or stories. It can explore failures and what breaks. It can try to break the software. It can explore non-functional attributes like performance and power consumption and usability. It can look at usage and look at how the user really does their workflow to get the job done. It can be end-to-end, following a transaction through all its processing steps. It can be creative based on your experience, your imagination. As someone who's seen many projects, you get a lot of experience, and you get a lot of creative approaches to coming up with charters. It could be stateful, if you have a stateful system, like state modeling of a system. It could involve sequences and orders of operations. It could involve data, different types of data from different sources to different destinations. Could involve studying the behavior of the system in different environments, different operating systems, different locales, different languages, different devices, different network protocols. And it could also be a white box where we actually look at the actual code that's modified and exercise it to see that the code that exercised does what it's intended to do in the system. We'd probably do this white box chartering paired with the programmer in the IDE, in the development environment. But there's a multitude of charter types. I've described probably 25 different types in quite a lot of detail in some of the reference materials, notably the draft book that I've included in the course materials called Charting the Course, Coming Up with Great Test Ideas Just in Time. And you see tons and tons of ideas for different charters. There's no limit to what can be in a charter, but a charter statement is always focusing the tester, focusing on learning about a specific thing. Now, a type of charter that I want to encourage people to start with on their project is called a reconnaissance charter. In a reconnaissance charter, we stick our nose everywhere to learn about things. We stick our nose everywhere to learn about things. So there's a nice metaphor with a truffle snorting pig, which is something that you might see in France, for example, where the pig goes in the field and the farmer harnesses it, and the pig looks for truffles. And the truffles are very, very valuable fungus that live under the roots of bushes. When a pig finds one, it gets excited. The farmer says, "Whoa, piggy," and the farmer grabs the truffle, puts it in the satchel, and continues on to find more and more. And the pig is happy for having found the truffle. So what I'm talking about truffles is now reconnaissance. We're sticking our nose everywhere, trying to find valuable information. In a reconnaissance charter, we're trying to learn about what we're going to be working on, what we're going to be testing. We're trying to identify things. We're trying to identify interesting things to explore, new testing ideas, and basic capabilities of the product. And we can get good ideas in Reconnaissance from all sorts of documentation, even stuff that's out of date, because maybe at some time when it wasn't out of date, it had some meaning to someone about the project. Here's an example of a Reconnaissance charter. This one comes from a project to explore a mind mapping tool called FreeMind. It's an open source mind mapping tool. And the charter is Reconnaissance. So the project is to see if FreeMind is useful for taking notes during session-based testing. That's the version and the session size. We're going to do 90-minute session of testing on this, or start with that. And the charter statement is this: identify capabilities and areas of potential instability of FreeMind. Identify what the product can do, and if there's anything that's risky about the product. So we're trying to look for what it does, and is there any risky things in there. Exercise. When you see a capability, it's not just enough to write down, hey, there's a menu that says to open the file. Demonstrate it works by trying it. Try each capability at least once when you discover it, at least once, with data typical of the intended use of the application. We're not saying when you find a capability to test it with all sorts of permutations and combinations and all sorts of stuff like that. No, what we're trying to suggest is that when you identify a capability, try it with data typical of its usage to make sure it's really there. So you've seen it, you've tried it, you've done it at least once, and we basically have some sort of record of what we tried. So that's the charter here for Reconnaissance, and I urge you, for any time you're doing testing on a project, to start with Reconnaissance charters. At the very least, you're going to be confirming that what you're delivered is what was intended to be delivered. And you sometimes will find, doing recon, very, very quickly, important bugs that block basic capabilities from doing their job. So it's a nice starting point on any testing assignment. All right, let's look at the organization of exploratory testing. First of all, it's important that we have skills, abilities, and tools to support test design. Now, in this lecture, I'm not going to teach test design, but I want to emphasize that during exploratory testing, we are expecting people to design tests on the fly. So I expect skilled practitioners of exploratory testing to know several test design techniques and get very good at them. And indeed, to treat them like the blades of a Swiss Army knife. So you choose the appropriate blade for the problem at hand. So in test design, we got to know what a bug is. So what are we going to do with the bugs? Do we have a priority scheme, a severity scheme? What type of problems are we looking for? So that's one. Understand our bug flow. So what does it mean? What are the priority schemes? That means how soon are we going to fix it? What are the severity schemes? How much danger could it cause? What's good enough? What's a reasonable type of problem that we're looking for? And we don't want to waste everyone's time with cosmetic bugs if we're going to ignore them, or spelling mistakes if we're going to do something with that later. So we're going to find bugs that matter. The test design techniques that are on your blade for the Swiss Army knife are things like variable identification. Identify what are the conditions, factors, inputs, outputs, data that influence the behavior, or should influence the behavior, or could influence the behavior of the system under test. Variables, so it's something that can change, that will influence or could influence the behavior of the system that we're testing. There's domain analysis. When you find a variable, categorizing into sets the different types of values a variable can have. That's domain analysis or equivalence partitioning. Then there's boundary testing. That's exercising extreme values. So these are all blades, right? They're all test design techniques. They'll all yield different types of tests and test data. Usage scenario test design, where you walk through scenarios from beginning to end, varying all the parameters that someone can enter, or decisions people can make. Control flow test design, when you can represent part of what you're doing with a graph, with a directed graph, and then find different pathways through it that are interesting to exercise and test and learn about the application. There's decision tables when we have conditional logic, multiple conditions, multiple actions. We want to basically create something that's very similar to truth tables, logic representations that help us identify the business rules that we want to test, or the domain logic that we want to test. State models, if you have a stateful system, identifying state models and then using that to drive your testing. Some people call that model-driven approaches to testing. Pareto analysis, if you have this, it's understanding the transactional usage of the system and knowing the sweet spot. What are the 20% of the transactions that happen 80% of the time? That's a natural Pareto distribution. And there's combinatorics testing, pairwise testing, where you basically try to say, okay, let me try to find for all of the variables pairings, every possible value of A with B, every possible value of A with C, every possible value of B with C. So the pairings of variables, that's pairwise testing. All of these are blades. All of these have different methods, tools, and techniques, and all of them might make sense on any given charter, on any given project, on any given day of the week. Other types of test designs, I guess, failure modes, where you look at the design and see what, ask the question, what happens if this breaks? Constrained pairs is a combinatorics testing, which has sort of limitations to what is allowed. So constrained pairing. And then permutations is just that. It's permutations of the value orders of operations, for example, sets of variables, different permutations, try them all in different orders. Now, you have the sort of Swiss Army knife with blades of test design techniques, which you're going to have to develop on the fly. So you're going to see a problem, you'll choose on the fly the test design technique, and then you will design the test as you're testing and take notes of what you've learned, right? You're recording what you've done. So we don't have our tests designed in advance, but we're still designing tests. And it's not really good enough just to design tests to figure out clever input combinations. It's also important to have sort of strategies to assess correctness. And in exploratory testing, we have not done tons of upfront analysis to figure out what all the expected results are. So assessing correctness, it becomes a very important part of exploratory testing. And the strategies for assessing correctness are often called test oracles. So a test oracle will be a strategy for assessing correctness. Let me give you some examples from the world of television. So there's a game show on TV, still popular, I understand, called Who Wants to Be a Millionaire? So Who Wants to Be a Millionaire is a game show, and in it, you're asked a bunch of questions, and as you answer more questions, you get closer to winning $1 million. If you answer all the questions correctly, you win $1 million. Very few people make it all the way to the top, but on the way, if you're not sure of the answer, there are strategies to assess correctness. There are oracles that you can use. So the test oracles in Who Wants to Be a Millionaire are called lifelines. So when I'm doing exploratory testing, I like to, before I start, make sure I've set up my lifelines. So this lifelines model works very well for me when I'm doing exploratory testing because I haven't done all the analysis up front. I have sort of strategies to assess correctness without upfront analysis. For example, in the TV show, if you don't know the answer, you're allowed to call a friend. That makes sense. Why not, while we're doing exploratory testing, make sure that somewhere at our disposal is a subject matter expert. Let's say what you're testing is, I don't know, you're testing a REST API, and you want to make sure that you know the proper syntax for REST API. Well, you might want to say, okay, while I'm testing, if I run into a syntax question on REST APIs, I can call Fred. Fred's an expert on REST API syntax. He can help me. He's a subject matter expert. So this is cool. That's great. He's available. He's not testing with you. He's not sitting next to you, but he's there. Maybe he's on Slack. Maybe he's on a quick phone call, but he's accessible to you while you're testing. He knows you might come up with a question, but he's busy doing his own stuff in his own place at his own time. He's just available to you if the need arises for you to help you assess correctness. Otherwise, you might also have maybe a test domain expert. Let's say you're doing exploratory testing to understand a little bit about the subject of performance. And you're not a performance guru. So you might want to have a performance engineer at your disposal. So a test domain expert, or maybe if you're doing usability testing, have a human factors expert available. These are not people, they're not pairing with you, they're not sitting with you, but they're available to you in case you need them, in case you have a question while you're testing. Other types of oracles, look at the TV show. 50-50, eliminate half of the answers. Well, we have strategies that do this. Eliminating half the answers might be a heuristic strategy. It's a sort of a rule of thumb. As Sherlock Holmes was quoted as saying many times in the books and stories by Arthur Conan Doyle, if you eliminate the impossible, whatever's left, no matter how improbable, must be the truth. So eliminate the impossible. So what 50-50 does is eliminate the impossible. In terms of software testing, what this could be is a rule of thumb that will eliminate wrong answers. It won't tell you the right answer, but eliminate wrong answers. For example, if a number is supposed to come on the screen and it's supposed to be positive, well, you know if it's negative, it's a bug. You don't know what the expected result is, but you know it's supposed to be positive. So if it's negative, it's wrong. There's a lot of accounting systems that have these rules about if something is evenly divisible by 11, it's correct. Whatever. There's rules of thumb in different domains. I don't know it. I'm not part of every domain, but almost every domain I've ever been involved in, there's been a rule of thumb or a series of rules of thumb. And domain experts tend to know these. And then the last test oracle is ask the audience. Now, ask the audience in a TV show is great. There's a big audience there and everybody votes. And the audience is almost always right. There's actually a book about the audience being right called The Wisdom of Crowds by James Surowiecki, where he basically says if you have a wise crowd, a group of people who have learned things independently and have a variety of different factors like the different education or different types of work or live in different places or have different cultural needs, well, this basically is a wide variety of people. They tend to aggregate on the correct answer. Now, Surowiecki's book is a brilliant treatise on the subject. I urge you, if you're interested in the wisdom of crowds, to read about it. But for me, the practical side of this is, in terms of asking the audience, a heuristic is as an oracle, is to consult my peers. Very often I'm working on an agile team. I've got between 5 and 10 people working with me. If I am working and I'm testing and I'm exploring and I run into a conundrum, I run into a problem, I'm not sure if it's right or wrong, I'm not sure if I should go left or right. Well, what I try to do is formulate that in terms of a question. Then what I will do is I will gather the troops. I'll get my agile team together, gather the troops. I might do this on Slack or something, and not in person. I will explain the conundrum, 5 minutes or less. This is called a lightning talk. I will explain the conundrum. And then I will ask people very quickly, without a lot of analysis, what would they do? And try to turn this into a multiple choice thing. Go left, go right, A, B, C, D. They give me what they would do. I try to aggregate that information and I use that to guide me. I make the final decision, but their input helps to guide me. So that's basically ask the audience, effectively consult your peers when you get to a conundrum. And these are strategies to assess correctness. There's a whole bunch of specific ones to testing. That there's what I call test heuristics, and there's a bunch that I like to use. They're rules of thumb. They're basically guides to your exploration. They're guides to your testing. They're not always going to help you, but they almost always do. They're failable, right? So they guide your exploration. They're rules of thumb, and they're failable. And there's a very famous tester I work with called John Bach, and his father wrote the book Jonathan Livingston Seagull, and John was named after the seagull in Jonathan Livingston Seagull. And in any case, John Bach loves exploratory testing, and he wrote some articles in the 1990s and early 2000s about charter-driven, session-based exploratory testing. He's a big advocate of this, and he always loved the heuristics. And he had a heuristic model when he traveled, and right now he's responsible for life site quality at eBay. So he basically travels a bit on his business. And when he goes to a new town, he likes to get his favorite hamburger. And his favorite hamburger is, if I'm not mistaken, from Burger King. This is not a sponsored talk. He just loves Burger King. So he basically tries to find Burger Kings. And he has a heuristic for it forget about using Google, and he does this with line of sight. He looks at the horizon outside of his hotel, and he looks for a big giant M. And when he sees the big giant M, he walks towards it, and almost always within a couple of blocks, he finds a Burger King, even though the sign he sees is McDonald's. And his heuristic is based on the premise that McDonald's always has conspicuous signage, and Burger Kings are usually close to McDonald's. And this is true. It's not always true, but it's true. Of course, very often, and often enough for it to be a valuable heuristic if your goal is to find a Burger King. I love his heuristic, and twice, a couple of years ago, I was in Copenhagen, Denmark, and I had the opportunity to try to go around there. I went to the old town, and I saw this giant M in the air. And I said, aha, let me see if I could find the Burger King. And I basically started walking towards the M, and right underneath the M, where you would have expected to find a McDonald's, there was a Burger King, and there was no McDonald's anywhere. And I couldn't believe it. I said, wow, this heuristic is really good, but where's the McDonald's? And I came back a second time, and I did the same experiment, and I just couldn't find the McDonald's. There was a Burger King right under the restaurant with the giant M. So I told this story at a conference in Holland a couple of years later about the heuristics, so failable heuristics that can work in extreme cases. And everybody started laughing at me because I found out that those big M's in Copenhagen was actually the symbol for the metro station, for the subway in Copenhagen. And it wasn't the symbol for McDonald's, but it was exactly the same icon as the Golden Arches. So I learned my lesson. Still, the heuristic was useful. But remember, heuristics are failable. So they're not always going to give you the right answer. They're usually going to point you in the right direction. Some heuristics, when I'm designing tests, CRUD. So whenever I find persistent data that's going to be there after my testing, I see, can I create it, read it, update it, delete it? And also I want to check, can I set it to an initial condition? Can I save it? Can I restore it? Can I migrate it? So I want to look at everything I can do with that data and make sure that I can manage the data. That's persistent data. When I find persistent data that's going to be there after the transaction, I want to try my CRUD heuristic. Goldilocks heuristic, modeled after the fairy story Goldilocks and the Three Bears. Goldilocks, whenever she saw something, she always sort of said, this one's too big, this one's too small, this one's just right. This one's too short, this is too tall, this is just right. This porridge is too hot, it's too cold, it's just right. This bed is too soft, it's too hard, it's just right. Always Goldilocks would partition things into three categories or three classes. And so the Goldilocks heuristic for me is whenever I see a variable with a range of values, I always want to test too big, too small, just right, just like Goldilocks. When I find a variable, I want to take AIM, that's my heuristic, AIM. I try to remember that. I want to choose values varied based on the application logic. That's the business rules. I want to choose values based on the input method. That's how data gets there. I want to choose values based on how something is stored or processed in memory. So for example, if I'm doing a calculator and the application logic is telling me how to compute a square root, I'll choose values based on how to compute a square root mathematically. So positive numbers and negative numbers, for example, are treated differently. Whole numbers and perfect squares and numbers with floating point parts are treated differently in computing square roots. That would be the application logic. The input method, well, someone's typing in a number. So they could type in a number or text or other things. So that's ideas based on the input method. And memory, I'd have to look at the code or talk to the program and see how things are stored in memory and choose values, for example, that exceed the storage requirements. So if it's stored in an integer that holds 3.4 billion plus or minus 3.4 billion, well, I'd say, well, what if it's higher or lower than that number? And those would be interesting tests based on memory. So AIM. I look for testing a variable from the point of view of application logic, input method, and memory. The baby step heuristic, whenever I see an object that can be constructed, I try to do it basically in one shot and then one thing at a time. So let's say your job is to compute the shipping rate or test the shipping rate calculation for Amazon.com. Well, what I would do is start with put a bunch of stuff in the shopping cart, look at the shipping rate. Then I would reset the whole thing and put one item in the shipping cart, log out, log in, put another item in the shopping cart, log in, log out, etc., until I've replicated the original one. And then I want to see, does the shipping rate match? And I found great bugs by this baby step heuristic. It's side-by-side testing, and you actually don't have to know what the expected result is to find important bugs in the system, and which I've done in the past many times. Then there's the action effect heuristic, where the basically whenever I find a condition that triggers an action, I look for other actions caused by those conditions or other conditions that trigger the same action. So that's looking for other ways to do things, hunting them down, trying them out. And one of the other heuristics I really love is called the triangulate heuristic. When I use this, I basically try to find 3 ways to assess correctness. I don't like to just work with one. That one could be wrong, or it could be just by fluke that gives me the correct answer. So I try to find at least 3 independent ways to assess correctness. So one might be confirming the value on the screen, confirming what's in the database, confirming what's in the report, confirming what's in the log file, etc. Even putting in something in the debugger, looking at a value in memory. So this is to basically have multiple ways to assess correctness. So that's some example heuristics for test design. As we're testing, we're doing exploratory testing, we're learning. We're learning about the system under test. We're concurrently learning, and we're designing and executing tests on the fly. So that's the sort of nature of exploratory testing. It's what we do. It's why I believe people should have a lot of test design skills to do this type of work. Dr. Kem Kainer published this very romantic sort of definition of exploratory testing, where he says exploratory testing is a style of testing emphasizing personal freedom, responsibility of the individual tester to optimize the value for work by treating test-related learning, design, execution, and test result interpretation as mutually supportive activities that run in parallel throughout the project, not just in one phase, in one order, in one time, following one process. So that's Dr. Kem Kainer, pioneer in the field of exploratory testing. Exploratory testing helps us on any project fill gaps, especially if you have a lot of people today are advocating exploratory testing, advocating automated testing. Well, there's some things that are holes, omissions, and gaps in your automated testing that possibly would be unlikely to fill at any reasonable cost with automation. So you can find a lot of interesting risks and problems in the gaps with exploratory approaches. Exploratory testing is wonderful to seek out and discover unexpected emergent behavior, which could be a side effect of a change, a weakness that's introduced in the technology, or other surprises you may run into. And of course, exploratory testing fits very nicely in the world of non-functional attributes of a system, where it sort of works out that you're going to be doing experiments to study these behaviors, to study, do we comply to security, usability, performance requirements. While we're doing our exploratory testing, during a session, it's very important for people who are doing this type of testing to take notes. In fact, at the end of the session of testing, our deliverables include our notes. What is a survey of what we did? We might also have a list of bug reports, a list of issues we identified, some screenshots. I like to video everything that I test. So all of these things are deliverables of the exploratory testing. So exploration notes become very important. I like to suggest it's important to take notes about decisions we made. So I want to know, what's the thinking? Why did we go this way instead of that way? Or what was just a flipping a coin? I want to see where we went and what we've discovered, what we've learned about. You could take notes in all sorts of different forms. I was talking about mind maps as one form, but you can maybe use tables or spreadsheets. That's an Excel spreadsheet from Lewis and Clark in 1803. You could include images, diagrams, schematic forms. That's an actual image in a document from Lewis and Clark, 1803. In exploratory testing, we do not know the test cases in advance. We define them on the fly. Therefore, we should somehow document what we tested and what we tried and what we learned. So documenting our testing is something that we're doing while we're testing, not before we're testing. So it's important for people who are going to be doing exploratory testing to hone up their skills in what I say is map making. It's note taking, actually. It's important to develop a sort of consistent style, generally considered good to be clear, terse, and frankly, every single session have at least one peer review the notes with you. So the notes are something that should be reviewed and frankly acted upon as soon as possible after the session is finished. It's not just something you put in a file folder and never look at again. Sometimes people follow a template. I'm not a fan of templates in software engineering, but note templates are important if you have multiple people working on the same project and you want to start sort of aggregating information. So it's a great way for people to share their findings. What do people take notes of? Well, what functions or options did we try? Observations, comments, images, any other attachments? Observations and hints for future testing. Of course, the configuration environment, date, time, that stuff, what we're testing. Who is doing the session? How did we assess correctness if we came to assess correctness? And pretty much any other relevant detail. Now, these notes do not have to be written in essay form. Very often, they're kept in a point form list. We also keep track of time. This should work out on your project to see what you want to do. But in testing, some of our work we could say is set up. So how much time did we spend in setup in the session? Did we spend 20 minutes of a session doing setup, or did we spend an hour of a 90-minute session doing setup? You know, we don't want to know about these things. While we're testing, it's important for people to stick to the goal of the charter, but sometimes there's important distractions that come up. So we want to basically record what percentage of the time were we on charter or off charter. Were we interrupted for other reasons? When I do a session of testing, I like to suggest that it's uninterrupted. I don't look at my email, I turn off my phone. I'm absolutely uninterrupted for the session. And I've agreed on what the session time is before I start. So if it's going to be an hour, it's an hour. If it's 45 minutes, it's 40 minutes. A typical session in a commercial project is probably about 90 minutes. Longer than that is rare, except for the case of non-functional testing, where we do tests that might sometimes take a couple of days. So notes, keep them terse. Templates are good for notes. Timestamps are handy. Whenever I take note, put a timestamp in there. When did you take the notes? Try to keep a professional tone, and don't duplicate stuff that's already in a bug report, for example. So you might point to it. You might put the bug number there. You don't have to re-describe the bug in multiple places. Don't write a novel. Don't point fingers, especially don't start a blame game. These are very, very political things sometimes. Don't be too casual. Certainly treat each bug with importance and advocate them well, but don't basically rewrite the bug reports. There's a tool that I like to use for note-taking in charter-driven session-based exploratory testing. It's called Rapid Reporter. You could find it online. There's versions of it that work on Windows and on Macs. It's a free tool, and it lets you take rather neat notes while you're doing testing. Doesn't interfere too much with the world around you. Of course, people, sometimes they just use Notepad. Sometimes they use fancy mind mapping tools. Any note-taking tool you want is handy for exploratory testing. But if you look at Rapid Reporter, it's got automatic timestamping. It's got notes of who did what type of note is taken. And you'll see that it can include screenshots. If you click on these, it expands to an external screenshot. And you can have things in there like, if I'm not mistaken, I don't have it here, but I have attachments, Word documents, etc. So we have a relatively neat note taker. It's not verbose, doesn't require you to do a lot of writing, but it keeps track of a lot of stuff for you. It helps you keep track of a lot of stuff. So that's note taking. A session. So how long is a session? I mentioned this before. The sessions, typically they're about 2 hours or 90 minutes to 2 hours of uninterrupted testing focused on a specific charter. Maybe it's possible to have short sessions. I know this for mobile devices. Some people have very short sessions, 15, 30 minutes maybe just for bug confirmation, it might be cool. And if you have non-functional stuff like performance testing or security testing, that might necessitate several hours to days. But before you start the session, you should agree on what a session time is. And at the end of the session, we're going to review what we've learned. So at the end of the session, it's like hitting a great big invisible pause button in the sky. And we basically stop. we can resume later if we need to, but we stop testing at that time. The session is over. We review our findings. We will work with someone else, either a peer, maybe the programmer who wrote the code that we're testing, maybe our lead, and we'll review what works, what doesn't work, what we have learned, and maybe what we need to learn more about. And we'll ask the question, did we learn enough? Would we benefit from another session on the same charter, or should we try a new charter? And this is of course, something you don't know until you finish the session. Sometimes you finish the session, you say, hey, it was very stable. We tried the stuff we wanted to try. We haven't tried everything possible, but we think it's stable enough. Let's move on to a more risky part of the software. So sometimes you do that. Sometimes you might say, okay, I tried it, but it worked out that I was only able to try about half of the features. I'm going to need another session or maybe 2 more sessions to wrap it up. So you make a decision, do you continue or move on to something else? And each session, of course, has independent notes about the session. A process that is often followed to implement this type of testing, very straightforward, very straightforward. And this would work in life cycles, agile life cycles, structured life cycles, waterfall cycles. Doesn't care about that. It's just the approach to the process of session-based exploratory testing. So we begin with a kickoff. This is actually a meeting. The person usually who wrote the code and the person who's testing the code, we get together and they just confirm the charter. Does the charter still make sense? Is it relevant? Is it cool? Should we tweak it? So first step. And this, my dream is it takes less than 5 minutes, but it's very important. Before you start testing, talk to someone who's your lead or who's the person who wrote the code. Make sure the charter is relevant. Make sure you're on track. Tweak and adjust accordingly. You prepare, get your environment ready, data ready. This could be quick. This might be a big thing. Depends on what you're looking for, but this is a preparation step first. Then we run our session, as I keep mentioning, whatever your session time is. And during it, we're going to design and execute tests and take notes of what we discover and what we learn. Then that pause happens. We basically complete, we wrap up, we gather our notes, we make sure our bugs have been reported, all this type of stuff. So we wind down the session. Then we review with the same person we kicked off. I like to do this as soon as possible after the session. Although some people don't do it immediately after the session, I encourage you to do it the same day if you can. If you wait a day or two, you're going to forget some important details. So review the findings, take a look at it and try to decide what to do next. That's the follow-up. We reassess our goals, put our notes in our bug tracking tools and in our session management tools, our agile project management tool. You might have it as a task as attachment, and move on. Move on to the next charter, move on to the next testing activities. There's a little bit of work that's been done researching, does it make sense to do paired exploration? And some people really like to do this, other people find it a bit tedious. So I just want to chat a little bit about pairing, and I urge you in your project teams, when you're starting, especially doing recon, pairing is an excellent way to start. That's 2 people working at the same time, fulfilling a charter, and you might have one person taking notes while the other one is driving the application and switch back and forth from time to time. So one thing we could do is paired exploration with other testers. So basically 2 people with testing skills working together. This improves your observation. You can feed off each other's experience. It's a little bit like the practice of extreme programming, where we do a lot of paired programming. We always have 2 programmers at the same time. So this, of course, working with other testers improves your observation skills. We don't want to suggest this is more efficient. If your goal is to find more bugs, you'll probably find more bugs if you have 2 testers working on different charters. But if your goal for this particular piece of software is to improve your observation skills, which to me is important during reconnaissance, but also important probably during critical bug fixes or testing critical features, then pairing makes a lot of sense. Pair with developers, that makes sense too. This is a white box perspective, to take a look at the system while it's in the development environment, look at what it's programmed to do, look at what it's supposed to do, and make sure they mesh, make sure they match together. Pairing with subject matter experts might make sense. Subject matter experts are usually not available all the time to us. If we can pair with them for a session or 2, especially when a new feature has been added, I think we learn things from a business perspective. And one of the great things subject matter experts bring to the table is the quick ability to identify missing functionality. I may never identify something that's missing. I can test what I can find, but if it's missing, I won't see that. Whereas a subject matter expert will see immediately if there's a piece of functionality missing. There's also the possibility of testing with pairing with test domain experts who are gurus in a specific type of testing, like usability testing, human factors, performance testing, performance engineers, security experts with security gurus. All of these are basically test domain experts you'd pair with. Not you're the application expert, but they're the test domain expert. They can really help you from the testing perspective. Sometimes it makes sense to pair with administrators. So because you're interested in installation and configuration of a system and conflicts with other applications on the network at the same time. Sometimes it makes sense to pair with end users. End users have a good sense of what the job is that has to be done. They might not always be domain experts, but they're people who have to use the system. They'll also be able to help you with human factors issues and pointing out things that are inconsistent. This drives users nuts if something is inconsistent. If you're dealing with users, you also may want to, from time to time, pair with a novice user, someone who's new to the system. Pair with them, and basically they're new to the software. They're going to ask great questions, and the questions of novice users almost always point to usability concerns. It's fantastic. Also, you might want to pair with an expert user. These are gurus, and they'll be able to tell you about the efficiencies of what you're doing, and also point out, as we were saying about domain experts, missing capabilities, like, for example, the ability to do macros and stuff like that, which experts may want to do all the time, but a novice would never think of. All right, so that's the end of the session on the topic of exploratory testing in practice. And I thank you very, very much.